Good morning and good afternoon, everyone. I'm Chris Spinagle from the Warning Decision Training Division. Along with me is Jill Hardy, also from WDTD. I'd like to welcome you to our sixth installment of our Revival of the Storm of the Month series. Today's presentation comes to you from the National Weather Service Forecast Office in Pueblo, Colorado. Our presenters are Tony Anderson and Greg Hebner, who will be presenting the Wild West of burn scar flash flooding. And with all that being said, Tony, the floor is yours, so go ahead and take it away.
Thanks everyone for joining us this morning and this afternoon. It's a little different today. We're not going to be talking primarily about tornadoes. There's one involved, but it's not the star of the show. Wildfires are a fact of life in the western United States. Fire control efforts have reduced the number of fires since the early 1980s. However, since the mid-1990s, the size of fires has increased. Fires are becoming larger and more intense. The fires themselves can last days, weeks, or months, but their consequences for the WFO can last for years. These fires can be extremely intense. High temperatures and long residence times can completely alter the hydrology of an area. High-intensity fires can remove vegetation from the forest canopy to several centimeters below the ash layer on the ground. When soil burn severity is moderate to high, a hydrophobic layer can form beneath the ash and the scorched soils. This layer is almost impervious to water. The closest model we have for this is the hydrophobic model in flash. The high runoff factor, unstable soils, and almost complete lack of interception creates extremely favorable conditions for flash flooding and debris flows. These conditions can last for years and directly affect how a WFO performs its DSS and its warning operations. The Spring Creek Fire started on June 27, 2018 in Costilla County, Colorado. It did most of its work in Huerfano County over the next 10 days, but was not declared contained until September. It was fueled by a drought that extended back to the fall of 2017. The winter of 2018 brought near-record dry conditions to the Sangre de Cristo Mountains. Dry conditions, high fuel loads, and high winds created an almost perfect firestorm. At one point, it was described as a 300-foot high fire tsunami. Eventually, 108,000 acres were consumed, along with 141 homes. Fortunately, no residents or firefighters were killed. The consequences for the landscape were drastic. Following many large fires, a burned area emergency response team is activated to assess the dangers posed by the burned area to designated values at risk. These teams are brought in as soon as possible and are often working while the fire is still burning. Part of their analysis is to compile a soil burn severity map. This map for the Spring Creek Fire is shown on the left. We'll add some creek names. Red is high soil burn severity and yellow is moderate. Both categories are capable of producing a hydrophobic layer in the soils. Both create dramatic changes to the hydrology of an area. 64% of the area within the fire perimeter was designated as high or moderate soil burn severity. This is a very high percentage. The southeastern portion of the scar, where the red oval is where we will focus our attentions today. 3 severely burned drainage basins emerge from the mass of red and come together just above the town of Veta. This condition created an immediate and very real concern within the office and within the first responder community. Just as meteorologists learn that evaporation is a cooling process, hydrologists learn that water flows downhill and gathers in low places. The town of Veta is downhill and in a low place relative to the burned area. Due to the extreme conditions and risk posed to Veta and other areas, and based on hard-earned experience, the WFO set its warning threshold at 0.3 inches storm total, or a sustained rainfall rate of 0.5 inches per hour. These will increase as the forest recovers and experience indicates the burned area can handle more water. This was not our first rodeo. WFO Pueblo had already dealt with the Hayman Fire in 2002, and more recently the West Fork Complex, Waldo Canyon, Junkins, and Hayden Pass fires. All had created flash floods and debris flows. However, we had not dealt with a fire this size since the Hayman fire in 2002. Based on past experience, we knew our outreach and DSS would be essential to success in a warning. We began our outreach during the report out by the Bear team with smoke still hanging in the air. We followed their report on how bad things were with a talk that reinforced their message and explained how the National Weather Service would be serving the community during that threat. Multi-agency collaboration during this time is essential. When one agency issues a warning, people can scoff. When 4 or 5 agencies offer the same warning, people listen. We spent a lot of time in Veta and in Huerfano County. Our 2 most important messages were designed to convince people that the land they once knew is completely changed and now poses a very real threat to them and to their community. The second part was to let them know that the National Weather Service would be there to keep watch and provide warning, but that false alarms were now part of their life. Folks are receptive when we explained our imperfections to them. They seem to understand that false alarms are necessary to make sure we catch all the real events. I'm going to pass this off to Greg Hebner now. Greg is our WCM and was the lead forecaster during the event in question. He'll take us through the meteorological and operational situation on July 22nd, 2019.
Thank you, Tony. Yes, I was the one, I basically drew the short straw that night. WCM have working radar operations, quick combination. This image here shows the proximity of the burn scar highlighted in that larger white circle, the bottom left-hand side of the image, comparison to the KPUX dedicated radar we have. Anywhere across that burn scar, we're looking about between 3,500 and 6,000 feet above the ground level. Given the elevation as well, too, we know hail contamination is a real threat, especially when looking at some of the deeper cores within the storms that are moving basically from west to east, from one side of the scar to the other side of the burn scar. All in all, though, given our radar proximity to this, and again, elevation differences across the scar itself, we can see the taller storms that produce the more significant impacts with the flash flooding and or debris flows. So typically, really any given summer day during the convective season, that is, we have an operational tempo. If we have a threat of some showers and storms that may produce some flash flooding and or debris flows, we'll have one forecaster dedicated to strictly just burn scar flooding monitoring and detection. The forecaster will be dedicated to DSS. Also, we have someone who's watching actions for severe weather in general, hail, wind, and tornadoes and that kind of stuff too. In this case as well too, it was a relatively large event taking shape on the 22nd of July last year. So we actually called Tony back in to help with some messaging and some of the warning operations. One of the nice things that we did heading into last year, again 2019 season, we started a text burn scar group, basically sending texts to both the county and the state liaisons for those burn scars, really to alert them, give them a heads up of potential storms moving towards or through the burn scarred areas. Again, really just say potential for the storm moving from, say, Castilla County, Highway 160. I'll show you that exactly where Highway 160 is in a few minutes. But then even towards the town of Veta, again, which was the most susceptible to any downhill movement of water and larger impacts as well too. But the constant communication we had with emergency managers helped us verify a lot of the reports you're going to see that occurred on the 22nd of July. So the image there on the right-hand side is an image that we actually inputted into AWIPS as another shapefile. So huge thanks to ITO Dave Metzi for helping to install the shapefile into D2D, again, to view and overlay with the rain cores in general. This burn scar was such a big burn scar, though, that we had to actually separate it into 3 different sectors. And we mostly did that at the urging of our emergency managers because they wanted to know exactly which basins were most susceptible to the heavy rain and impacts by the flash flooding and the debris flows. So to really kind of drill down a lot more, we sectorized it into this. And this is actually what one of the warnings that issued that might look like. And here I'm highlighting that we actually are calling out, again, via the shape files that we have through WarnGen, your burn scar south of Highway 160 in Castilla County, and also the burn scar south of Highway 160 in Huerfano County. So again, we're able to drill down to those finer basins that really let the end users know, most of the EMs at this point, exactly which areas or which creeks or basins are going to get hit the hardest. Now, looking at the synoptic setup that led up into the heavier rain event, we had a deep and long-fetched easterly upslope flow. Here I've highlighted some of the dew points that we had that afternoon and that evening. So we're looking at the upper 50s to low 60s. Now, I'm sure some of you out there are probably laughing the fact that I'll say that this was a very, very water-laden event for us here in southern Colorado. But when you're affecting those low 60-degree dew points into elevation, there's my mountains, very beautiful. You're basically pushing all that moisture into those mountains, orographic lift's taking place. Basically, dew points in the 60s will equate to somewhere in the mid-upper 70s along the coast. So again, a lot of juice was in place for the storms to really fire up on. And that yellow X there is the proximity of the town of Veta in this case, to where the moist upslope flow is coming in. We took a look back at some of the data aloft. I won't show this in this presentation, but this is probably one of the truer monsoon events we had last year with high pressure, mid-level ridging, kind of right across that mountainous area there. So we had some pretty good, obviously, low-level flow, as well as some northwest flow aloft, helping to bring moisture in from the Gulf of Baja area. This image here will show you the radar imagery really a couple hours before things really started to get going down there in La Veta. As Tony mentioned before, we did have a tornado. So, it seems like all these presentations have some kind of tornado involvement with them. And in this case, we actually did. So we had a pretty good setup, pretty good primed area across here. This yellow circle I just highlighted here is actually where the Junkins burn scar was. So we actually had two burn scars heavily impacted by heavy rains on the afternoon and evening of July 22nd of last year. And then the area down, I just highlighted there, and the larger yellow oval represents a pretty good idea of exactly where the Spring Creek burn scar is. And again, you can see some of the showers and storms developing really just to the west of the burn scar across the northern part of it as well too. Again, we had northwest flow in place, so expecting a lot of the storm motions to be from the northwest to the southeast. Now this is pretty much the meat of the storms in general, and you can see the warnings we had kind of oriented there throughout the evening and afternoon hours. Basically, we had outflows from the previous storms up to the north, where the tornado was, pushed off to the south again, via the northwest flow in place with the deep easterly fetch also in place, and just kind of caused basically worst case scenario we were thinking with this. They had ample fuel to work with, relatively slow moving, kind of anchored to the high terrain, and then began to kind of push off slowly to the east and southeast eventually. But as far as the warnings go, again, using our sectorization, we don't necessarily want to over-warn the folks who live in La Veta. So the first warning I'd issued, actually, I kind of kept the box out of La Veta, kind of wanted to see how the rain was going to play out across the majority of the burn scar. And as time went on, it became more and more intense, and it was needed to actually begin issuing alerts for the more populated areas in and around the burn scar itself. All right, Tony?
Okay, this is Tony again. This is the QPE from MRMS for the first hour of the event. As you can see here, the largest estimate for the burned area was 1.75 to 2 inches of rainfall, well in excess of our thresholds. And it's right in the headwaters of south of Beta Creek. All of that yellow that is highlighted flows directly into the town of La Veta once it hits the ground. We didn't realize it at the time, but according to the Atlas 14, we're dealing with a storm somewhere between a 10 and 2% annual probability of exceedance. The bulk of the rain in any one location generally fell within 1 hour. The Colorado Department of Water Resources installed 7 stream and precipitation gauges in and downstream of the burned area, specifically to protect the town of La Veta. The USGS then added 4 more stations to make the Spring Creek fire the most heavily gauged fire in the United States. These Sutron gauges report on the Iridium satellite network. They report hourly until a threshold is crossed, at which time they report every 3 minutes. Precipitation is only measured every 15, so that gets a little dicey. They report precipitation, stream gauge, and stream velocity. Stream velocity was a new physical element to us, but we were learning to use it. It provided some useful information that night. The real story was the precipitation data. As can be seen, the gauges reported about what MRMS estimated. The real benefit was the ability of the gauges to report in real time what was happening and reinforce the confidence we had in the radar estimates. As it turned out, this was the storm we had feared. High-intensity rain dropped well in excess of an inch of rain in all 3 basins that flow directly into La Veta. Worse still was the 0.95 inch and 0.82 inches in 15 minutes. That's about a 4 to 10% annual exceedance probability. Those are just the kind of high-intensity rainfall events that can generate debris flows. This is Middle Creek, the main creek draining the eastern slope of the burned area. This is on the burned area, well above the gauge in question. Middle Creek seldom floods. It is usually 3 to 5 feet wide and 6 inches deep. Some years it runs dry. We unfortunately had to mute the audio due to some colorful language used by the videographer. In their conversations, they do mention that they are going to lose their road for 3 or 4 days, and they were quite right. Their road and the main road into their community were both wiped out. This map shows the reports of flash flooding we received from on and downstream of the burned area. The first image is from in the burned areas of Middle Creek and south of Veta Creek, and just downstream. Roads were overtopped, culverts wiped out, even a railroad embankment was overwhelmed, and that event almost cost us an emergency manager. The second image is of the area further south, further downstream, and closer to La Veta. The largest observed flood was when the approach to the Highway 12 bridge was overtopped north of La Veta. We were fortunate. The flooding from the 3 major creeks arrived in La Veta in a staggered manner. If they had arrived at nearly the same time, conditions in La Veta would have been much, much worse. The take-home message from this particular slide is that we most definitely verified our flash flood warning. These pictures were taken on Middle Creek in October of 2019. We do not know which storm created this particular debris flow. I strongly suspect it was the event of July 22nd. It is, however, a great example of why we're concerned. The debris flow wiped out a road. The deposit was approximately 100 meters long, 2 to 3 meters high, and was strewn with boulders I estimate to weigh between 5,000 and 15,000 pounds. To imagine this heading down your road at 30 to 40 feet per second is truly frightening.
So these images here were actually taken the day after the actual flooding in question, maybe July 24th actually. And what basically I thought was absolutely amazing was really the amount of silt across the roadway. So on the left-hand side, you see all the silt and mud and debris kind of strewn across the road. That eventually, if you go farther upstream, this is the road that was washed out pretty heavily. Some of those boulders there, as Tony mentioned before, are also shown here at this elevation, what we expect to be about 15 to 20 feet above the stream bed below, as shown on the right-hand side. So really just the amount of force coming downstream or down that creek was absolutely tremendous.
If you want more information about post-fire hydrology and operations, we have several resources. There is a national post-fire hydrology group led by Catherine Rowden at Western Region Headquarters. That group is overseeing the compilation of a WFO post-fire playbook. We are hoping to gather the best practices and combine the experiences from across the West into a single source for offices experiencing their first fire or for new employees. Lastly, The post-fire group is working with Dennis Staley at the USGS to gather data for a study to determine accurate rainfall thresholds for debris flows. We're hoping to train National Weather Service employees to assist in data collection for that project.
So just quickly going through a few of the best practices, even lessons learned. The texting we provide to the Corps partners the last 2 convective seasons, it works very, very well, especially in the more cell-sparse areas. Some of the wording we put in our text is used actually in crafting some of the virtual message signs that the Colorado Department of Transportation uses, as well as some of the wording is used actually in code, red alert, or reverse 911 messaging. Tony's worked very hard to ensure that our warning staff is well-versed in our flash flood methodology and thresholds. And again, generating those local shape files was an absolute asset and game changer for us as well. One of the things I like to focus on more so next time is, personally, I focused too much on the hourly total versus the rain rates, and that's what really did a major bulk of the work was the rain rate. So next time, personally, and for our operations staff, focusing on rain rates more so than hourly. And with that, we really appreciate your time today. Thank you very much for having us speak to you about the Wild West of burn scar flooding.
I will say that that's the end of this Storm of the Month. I want to thank Greg and Tony again for a very interesting talk and a great discussion afterwards. We appreciate it. Thank you all for attending and sticking with us here till the end and asking a bunch of great questions, and have a good rest of your day.